Okay, this is still in section 3.3, the law of signs, and we're going to do a word problem here. And we're going to use a directional system that we use if you are taking Physics 30, you've probably seen it before. And that's where you locate a direction by stating two directions with an angle in between. So if you go north 50 degrees east, you'd go north first and then take an angle 50 degrees to the east of that. And what we're going to do is we're going to do this problem. It's similar to one in the book that we have, but a little different. I've got two planes are trying to locate an airfield. Plane B is 5,680 meters from plane A in the direction of north 51 degrees east. Okay, so that's from A to B. The airfield is located at north 32 degrees east from plane A. Okay, and north 21 degrees west from plane B. Okay, how far are the planes from this airfield? So what we're going to do is we have to draw the picture out and do it carefully. I'm going to draw quite a large picture. I'm going to try and center this now so that I can get the picture in here. So what we're going to do first of all is we're going to take the first statement. It says here is plane A. Okay, I'm going to call that A. And it says, okay, if this will be the north line right here. I'm just going to put a dotted line in here for reference. It says, now the direction that B is from A is north 51 degrees east. So go to about 51 degrees here. So 51 degrees, if we were drawing here, pardon me here, let me see. Oh, let's use a 60-degree angle here and get us an idea. So it's going to be somewhere in there, a little less than that. Now this isn't to scale, but it's going to be something like this. And that's to plane B, up there. Now also in the problem, it says that distance is given to us at 5,680 meters. Okay, now what we'll have to do here is we'll have to also locate where the airfield is. Now the airfield from plane A is given to us at 32 degrees from the north to the east. So north 32 degrees east. So if we take the 30 degree, it's going to be a little more than this. So it'd be something like this. I'm just going to draw, I'll just stretch it out a little bit like this. I'll just extend it way up there. I don't know where it's going to end up being there. But we know that this is 32 and that this is 51, leaving us for an angle in here of angle A of 19 degrees. If you do some geometry there. Okay. Now we have to draw, it says also the airfield is located and north 21 degrees west from plane B. So from plane B, if we go north again, we'll put a reference line in for north directions. And we draw an angle in here. Okay, north 21 degrees west. So north, and then we got to go west. So it's going to be like smaller than our 30-degree one, so let's just slide her this way a little bit. So we know that this angle up here is 21 degrees. Okay? And if we extend that, we can actually get an equal angle in here. Like if we take this point here, let's call this the field, F. Okay? That's the airfield. That's where it is. And at point F, don't worry about this line that I extended past here. That means nothing now. But we can keep it there. And if I extend a north line up here, and a north line down here, we can get these two angles by using, if you look at here, this is a transversal, and these two north lines are parallel to each other. So this angle is equal to this angle. So this is also 21 degrees in here. And then if you look over here, you get another one here. There's a north one here and a north one here. And there's a transversal there. So if we look, remember alternate interior angles form Zs. So if you look, here's that shape. There's a Z there. So this would be 32 degrees here. So that gives us a total angle degree for angle F. So angle F, what's that? 32 and 21. That's 53 degrees. So now you are getting quite a bit of information. You have 19 degrees and 53 degrees there. So now you know what angle B is. That's going to be 180 degrees, subtract 53 degrees, subtract 19 degrees, because all triangles add up to the measure of 180 degrees. So when you subtract these out, you get 108 degrees for angle B. So now we're set up, and we want to find this distance and this distance. We'll call this AF. That's the distance from A to the field, and we'll call this one BF. Okay? Now that we're set up and we have the drawing, we can easily calculate using law of sines here. So what's given to us, and I'm going to do it over here, we have 5,680 meters over which side is opposite of that? Well, or which angle, pardon me. Well, that's angle F is opposite of this side. So angle F is sine of 53 degrees. And that's going to equal, if we want to find AF, AF is going to be opposite of which angle? Well, AF is up here, and the angle it's opposite is 108 degrees. And we can do the same thing down here, 5680 over that sine 53 degrees to get BF over sine of, and opposite of BF is the 19-degree angle. Okay, so if we do our calculations here, okay, so this would be 5680 times sine 108 divided by sine of 53 degrees equals AF. And this would be 5680 times sine of 19 degrees. And then I'm just going to, instead of saying equal this, I'm just going to divide out the sine 53 right away. Will give us BF. So AF equals and BF equals, we'll calculate them now using our calculator. Make sure it's in degrees. So for AF, 5680 times sine 108 divided by 53 sine. 6,764 meters to the nearest meter. And then, of course, for BF, we do similar, 56.8e divide by, or sorry, pardon me, times by sine of 19 divided by sine of 53. 2,315 to the nearest meter. So now we can state a statement that we write a statement in there. The distance from the airfield to plane A is 6,764 meters, and the distance from plane B to the airfield is 2,315 meters. In our next tutorial, we'll be moving on to the next section, which is looking at the ambiguous case of triangles.